Hi, this is our third video of 1.1. This is regarding problems 15 through 28, and basically they want to know all these problems whether they're functions or not. And the first one's a mapping, the second one's a set of ordered pairs, and the other ones are just equations. And like I told you in my first video, you're going to be asked whether something is a function or not. And so let's begin with the mapping. And it says, is this a function or is it just a relation? And if it is a function, state the domain and the range. Now, is this a function? Well, remember, each input corresponds to one output. So right off the bat, Bob has two daughters. So Bob's an input. He has two outputs, Beth and Diane. So that is not a function. Okay? Now, John goes to Linda, Chuck goes to Marcia. And those are okay, but the problem is Bob. Okay, so each father, to be a function, each father has to have one child. Okay, so this is not a function. It's a relation. They have a, there's like a relationship, but there is no, this is not a function though. So since this is not a function, I don't have to state the domain or the range. But if it was, if I remove Bob from Diane, and then just remove Diane altogether, then it would be a function. And the domain would be Bob, John, and Chuck. And the range would be Beth, Linda, and Marcia. But as it stands, we have Diane here. And it's not a function. So all you would say is not a function, and you're done. Now, the next problem is number 19. It's the same idea, except it's not a mapping. It's a list of ordered pairs. So, whereas the x coordinates here are Bob, John, and Chuck, the x coordinate here are 2, -3, 4, and 2. Okay? So the question becomes, is any x coordinate repeated? Right here. 2 is repeated here and there. So even though they're side by side, 2 gives me 6 and 2 gives me 10. So it's not a function. So this one here is not a function. So what would make it a function? What would make it a function? Well, remove one of those ordered pairs. So if I remove one of the ordered pairs, let's say if I remove this one and have just those three ordered pairs, then now it's a function. So then what would be the domain of that? Well, that's the x coordinates, 2, -3, and 4. What's the range? Well, it would be 6, 6, and 9. You're like, wait a minute, it's not a function because the 6's are repeated. Remember, outputs can be repeated. It's not the it's the inputs that can't be repeated. So, so that would be a function, but it's just the domain would be 2, -3, and 4, and the range would be 6 and 9. It's the same output twice, so that's okay. But as it stands, with 2, 10 being there, it's not a function. And so you could probably guess what's going to happen on 23. Seeing those -2's in there, so none of these are functions. So not a function. Because the -2 is repeated. But if you either remove the -2 or the 4, -2, 4, or the -2, 6, just take it away, then the remaining 3 would be a function. So, all right. So now we're going to determine this one as a function. Remember, I gave you some little cheap advice on this, how to determine if equations or functions. If you have like a y squared, it's not going to be a function. If you have the absolute value around the y, it's not a function. But there are some that, namely this one right here, y equals, it's not y squared, but it's not a function. You'll see y in a second. But this one right here, number 28, is it a function? It's y equals x cubed. So y is to the first power. If I put a number in for the x, let's put 2 in. Well, what's 2 cubed? That's 8. So y equals 8. And that's okay. So 2x is 2, y is 8. So as it stands, it is a function. Let's make it y squared and see what happens. Is it still a function? Well, if you put 3 in, what's 3 squared? That's 9. It's only 9. It's not plus or minus 9. It's just 3 squared, which is 9. So yeah, that's a function too. So that doesn't matter. So y equals x cubed is a function. Now look at the next one. Y equals plus or minus the square root of 1 minus 2x. Now, if you put a number in, let's put in 0. 1 minus 2 times 0 is 0. That's square. I mean, 1 minus 2 times 0 is actually 1. And the square root of 1 is 1. But there's a plus or minus that number. So I saw the plus or minus right there, and I knew whatever comes out of that square root is going to have a plus or minus attached to it. That's two different numbers. So even though the y wasn't squared, I saw the plus or minus, and I knew right off the bat it was not going to be a function, because whatever comes out of the square root, whatever number you want it to be, you're going to have a plus or minus attached to it, and it provides two outputs. So whenever you see a plus or minus, that's another one of those rules, is if you see a plus or minus, not a function. So this one here is not a function. Now let's look at the next one. Y equals 3x minus 1 over x plus 6. Notice there is no y squared. There is no plus or minus. All I see is a fraction. So if you put a number in, like let's say you put in 5, 3 times 5 is 15. 15 minus 1 is 14. 5 plus 2 is 7. 14 divided by 7 is 2. And there's no plus or minus, so that's good. That's one term. So I saw y to the first, I saw a fraction on the other side, and it doesn't really matter what's over. I don't see a square for the y, I don't see a plus or minus, I'm good. So this is a function. But you're like, wait a minute, what happens when you put in negative 2? If you put negative 2 in, 3 times negative 2 is negative 6 minus 1 is negative 7, and negative 2 plus 2 is 0. You cannot divide by 0, you don't get an output at all. Remember, not getting an output is not a problem. It's getting too many outputs. So negative 2 is not in the domain, but it's still a function, because no matter what other number I put in an equation, I get one output at the most. I don't get 2. So even though negative 2 is not in the domain, it's still a function. So yeah, it's a function, but it's got a restriction. You cannot have x equals negative 2. And sometimes in later problems, they're going to be asking you for the domain. And this is what you look for. Is there a fraction? Yeah. Well, what makes the denominator 0? Well, in this case, it's negative 2. Well, throw that one away, and then every other number is going to be okay. But that doesn't have anything to do with whether it's a function or not. So once you determine it's a function, and you check that off your checklist, then you go looking for what's in the domain. They're not asking that for here, though. That comes a little bit later in the section. So, but this one is a function. And it's probably, most of you guys can see 32. If you looked at my first video on this, and you're saying, oh, I see a y squared, and I know it's not going to be a function. So, and that's a good eye. So, if you have 2x squared plus 3y squared equals 1, you put a number in. Okay, put 0 in for the x. You'll get 3y squared equals 1. And then you divide by 3 and you get 1/3. And then you got to take the square root of that. I'm doing a little bit of mental math in my head here. But you got to, when you take that square root, that automatically puts a plus or minus on it, and you'll have the same problem that you had on 32. So when you say y squared or a plus or minus, both of these are the same red flag actually. So same thing, the answer is 32. It's not a function. So, all right. So this concludes our third video of this one. So we did a little bit better time on this one. So the next problems on this video that we'll be watching, it would be problems 39 through 62, I believe. So thank you for watching.